8.8 Concentrations and Consumer Products. The concentration of consumer products can be written in percent volume per volume. This is used for liquid-liquid mixtures. We could also have percent weight per volume. This is for solid liquid mixtures. And finally, percent weight, and this is used for solid liquid or solid mixtures. And there are equations for calculating each of these different types of concentrations. Sample problem number 1, calculating volume from percent volume per volume. The concentration of ethanol in a 750 milliliter bottle of wine is 13.5% volume per volume. Assuming that the wine has the same density as water, calculate the volume of ethanol in the bottle. Let's look at our equation for the concentration of volume per volume. The concentration of volume per volume is equal to the volume of the solute divided by the volume of the solution times 100%. In this question, they give you the concentration of alcohol, 13.5%, and they give you the volume of the solution, (750 milliliters), and we want to calculate the volume of the solute, ethanol. We can rearrange this equation, and the volume of ethanol is equal to the concentration of the solution times the volume of the solution divided by 100. That's 13.5% times 750 milliliters divided by 100. If we leave the volume in milliliters, our answer will be in milliliters. And we end up with 101.25 milliliters of ethanol in 750 mils of wine at 13.5% volume per volume. Let's try a second example where we calculate the volume of a solution from the mass of a solute. Glucose, C6H12O6, is used to prepare intravenous feeding solutions. What volume of a 5% weight per volume glucose solution can be prepared using 125 grams of glucose? Let's take a look at our equation. The concentration weight per volume is equal to the weight of solution, or solute rather, divided by the volume of solution times 100%. We're given a concentration of 5%. We're given a weight of glucose of 125 grams. And we need to find the volume of solution required. We can rearrange this equation. The volume of solution is equal to the weight of glucose divided by the concentration of glucose in weight per volume times 100. That's 125 grams divided by 5% times 100. Punch this into our calculator. And we end up with 2,500 milliliters of solution. Let's look at an example where we calculate dilutions using percent concentrations. What is the final concentration when 125 milliliters of a 30% weight per volume hydrogen peroxide solution is diluted to 2 liters? So in this example, let's list what we have given. We have an initial volume of 125 milliliters or 0.125 liters. With an initial concentration of 30% weight per volume. And we're going to dilute this to 2 liters. And we want to know the final concentration. So initial concentration times initial volume equals final concentration. It's final volume. We can solve for the final concentration, divide both sides by V2. And the final concentration is equal to C1 V1 over V2. That's 30% times 0.125 liters divided by 2 liters. And remember, write 30% as a decimal. So we'll do that by divided by 100. So we end up with a concentration of 0.019% weight per volume. Extremely low concentrations are found with scientists working in the medical or environmental fields, and they express these concentrations as amount concentrations or percent concentrations, and that would give them very awkward numbers to work with. So for this reason, very dilute concentrations are often expressed in either parts per million, parts per billion, or parts per trillion. Let's look at an analogy. 1 part per million is equivalent to 1 drop in a bathtub full of water, or 30 seconds out of a whole year. 1 part per billion is equivalent to 1 drop in 250 full barrels, or 3 seconds out of an entire century. And 1 part per trillion is 1 drop in 20 Olympic-sized pools, or 3 seconds out of 100,000 years. For example, a bottle of water may contain sodium ions at a concentration of 36 parts per million. This means that there are 36 parts of sodium for every million parts of solution. This concentration is so dilute, you would have to drink 56 half-liter bottles of water to consume only 1 gram of dissolved sodium ions. Let's calculate concentrations in parts per million. Sample problem. A 1.5 liter sample of pool water contains 4.5 milligrams of chlorine. Determine the concentration of chlorine in parts per million. The concentration in parts per million is equal to the mass of the solute divided by the mass of the solution times 10 to the power of 6. So we have the mass of chlorine divided by the mass of H2O times 10 to the power of 6. So we have 4.5 milligrams divided by 1.5 liters times 10 to the power of 6. Now we're going to express the number of liters in milliliters. So that's 1.5 times 10 to the power of 6 milligrams, rather. If we punch this in, we end up with 3 parts per million of chlorine. Please try any practice problems on this section, as well as any LMS quizzes, and don't forget to read this section over.